Hello, everyone. Welcome back to your channel, Math Made Easy. Today, I'm going to start a new topic, and that's basically the polar coordinates. So, what are polar coordinates? We are familiar with the Cartesian coordinate. Okay. The x and the y, right? The polar coordinate uses r and theta. Notice you need two things, right? You always, if you want to specify a point in either system, you need x and y, meaning how many units do I move in the x, either right or left, and then the y up or down. Here, maybe I can show you this here. Here is a polar coordinate like graphing paper. So you see the angles, usually the angles are given in radians. I don't know, I printed this online and it turns out to be in degrees. I didn't notice until right before I started the session. It doesn't matter, it's the same concept, but usually you will find it, you will see a 0 and then pi over 12, pi over 6, pi over 4, and so on and so forth. And the point that corresponds to the origin in the coordinate Cartesian coordinate, it's called the pole, coming from the polar coordinates. So when we measure, what are the two things we measure? We measure r, which is the ray that goes from the pole outside in any direction. And then we have theta, which is the angle from the horizontal, or x in the xy plane, going counterclockwise until it goes back to 2 pi or 360. Okay? So how are they related? So if I have a point x and y in the Cartesian coordinate system, so let's pick a point, and let's say let's make it in the second quadrant, not the first. We always use the first quadrant, but we need to do something else. So let's say this point is -3 and 4. So x is negative, y is positive. And because in the polar coordinates, we have different circles, and here's the pole, we need two things. We need to find out the length of this line or that line segment. Okay, how can I represent that in the polar coordinate? Very easy. We know that x is that distance and y is that distance, and that angle is 90 degrees. What comes to mind right away? Yes, this is the r. So we are going to say x squared plus y squared equals r squared. So I can find the length of r quite easily. Then I need to find this angle going from the positive x counterclockwise. But we always know that since the x is negative and the y is positive, we are in the second quadrant. X is r cosine this angle, but it's negative, right? And it doesn't matter because you are going to say r cosine this angle, and this angle is obtuse, so you will get a negative value. And the y's are sine this angle, but the sine is positive. So in this case, if this angle is theta, then we can say that theta here that we calculate is the inverse tan of y over x. Notice y is positive, x is negative, so you get a negative tan, meaning the tangent is more than 90 degrees. We know we are in the second quadrant, and we measure theta from the x. Okay, so now that's how I can say, okay, theta is, say, maybe 100. Well, that because we specified that, then this would be the arctan 3 over 4 over 3. So we cannot just make up some number. You can calculate it. And that would be the angle theta. So what if I give you an r and a theta in the polar coordinate? So I tell you r and I give you theta. Let's say we are in the first quadrant. How would you find x and y? Again, very easily. You know that x is r cosine theta and y is r sine theta. Okay. So now let's find how we can represent the easiest two objects in polar coordinates. The first thing is a line. You know, if you have a line, then you already say, I know theta of that line, right? It's inverse tan y over x. So if I tell you, for example, tell me what is y equals 2x minus 3. You say, okay, the slope is 2. So theta is arctan 2. And you come here and say theta equals arctan 2. That's it. That's it. That's all what you need. Because once you specify theta, you would get a straight line extending from negative infinity to positive infinity that makes an angle whose tangent is 2. That's it. Okay? Again, you could have said r cosine theta equals 2, r cosine theta minus 3, and then there is no reason for that. A line is very simply, you just specify the angle. Notice that this is a line passing through the pole or passing through the origin. Okay, that's the equation of that line. Another thing that's very easy to find is the equation of a circle centered at the pole. Notice that if for example, let's say example r equals 5. We know here we write x squared, same thing, x squared plus y squared equals 5 squared. But x squared plus y squared is r squared. So if I want to write it here, I would say r squared equals 25, but I can take the root and the radius cannot be negative, or else even if you say it's negative, we can come to that later, r equals 5. In fact, it's plus or minus 5. That's an equation of a circle in the polar coordinate that is centered at the origin. Because we are saying r equals 5, and then I ask you, what is theta? You say any theta, meaning if I rotate it like that with r equals 5, it's okay? You say yes, because I didn't tell you I didn't specify theta. So if I fix theta, it's a straight line. If I fix r, it's a circle. And since we mentioned circles, I want to go a step further and tell you if that circle touches the x or the y, its equation also is very easy. Let me show you that in a second. Suppose I give you this equation and I say r equals 4 sine theta. I look at that and I say, okay, that's an equation of a circle whose diameter is 4, okay? And it's touching the x-axis, but it's above the x-axis. You say, whoa, 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 how did you know all of that? Well, I know that r is the diameter. Why? Because if you say theta is 0, you get sine 0 is 0, so r is 0, meaning I am at the pole. If I make r 90 degrees, pi over 2, meaning up here, this is 0, 90 degrees. Sine 90 degrees is 1, and 4 times 1 is 4, so r is 4. And you can see that this would be a circle whose radius is 2, and the sign is telling you, is it drawn in the y direction from the pole or on the x direction from the pole? If it's positive cosine, the circle is to the right of the pole like that. If it's negative 4 cosine, it's like that. If it's 4 sine, it's like that with the x-axis. so to speak. And if it's a negative sign, it's below the x-axis. Very simple. But suppose you don't know. How can you find out? You can easily specify a few thetas for which you know the sign, and maybe where the sign is easy to find. So I would have a table here that gives me theta, and then sine of theta, and then r, which is 4 times sine of theta. Now I say 0, 0, 0. I know sine 30, right? Usually we write pi over 6, but since this is made in degrees, I'm going to write it in degrees. If theta is 30 degrees, then sine 30 is 1/2. 4 times 1/2 is 2. If it's 90 degrees, sine 90 is 1. 1 times 4 is 4. If I say 150, that's also 1/2, so I get 2. And then when I say 180, I get sine 180 is 0, so I get 0. Now, if I say 210, I am in the third quadrant, so I get negative 1/2 times 4 is negative 2. If I say, maybe we don't have to. Then we would do 270 so that we don't end up with radicals. You can do 45 and root 2 over 2 and then 2 root 2, which is roughly 2.8, right? But these, at least we know exactly the point, and we'll see how it works. 270, that's negative 1, so you get negative 4. 300, you get negative 1/2, so negative 2. And then finally you get 360, which is the same as 0. You get 0, 0. Now, you get this thing, and you say, when the theta is 0, I get 0. So that's the pole. That's the pole, yes. If it's 30, I get 2. So let's say each one of these circles is 1. So 1, 2. 2 on here. So I am here, and then that. And then at 1, at 90, I get 1, 2, 3, 4. That's the point. And then at 150, I get 2 again. Yeah, 2 is here. For some reason, I don't know why And then at 180, it goes back to 0. $210. Notice that I only need to go to 180. We already have our circle here. Circle of radius 2. So its center should be here. Let's try to see if I can open that. Oh, wow, almost. Okay, roughly. So if I draw a circle here, do you see that this circle would be tangential to the x-axis above it and has a diameter of 4? Notice that if you say 210, 210 is in this direction, but it tells you it's negative 2. So you have to go opposite. So you get the same point. So you will get these 4 points back. If you continue to 360, you don't need to do that. That would be 2 circles. So basically you are drawing it for theta greater than or equal to 0, less than or equal to pi. That's it. It will give you a circle. So easy, very easy. Sine, it's opening in the y above. Negative sine, it's open y below. Cosine is opening x to the right. Negative cosine, it's opening to the left. Okay? And then just to finish, I'm going to show you that if I change the sine or the cosine, if I change the theta, I multiply it by any integer number. So for example, I say r equals 3 cosine 3 theta. That will give me a rose. What? Yes. In fact, you can think of that as a rose with a single petal. All the rest fell out because it's r equals sine theta. Theta meaning one petal. 3 theta meaning 3 petals. And because it's cosine, notice 3 petals distributed equally on the 360 degrees. And because it's cosine, it will start with the x-axis. Of course, we don't have x and y axes, but we have angle, 0 angle and 90-degree angle. It will start, it will have a length of 3 here, and it's going to look something like that. Then you go 120 degrees, meaning 30 degrees here, and you measure the same distance. Let's say this is 3, and you get another petal. Of course, they're not the same size. And then you get 240 degrees, and let's say we get a third petal. And you get something that looks like, you know, the fan with 3. But of course, this is much longer than that. But if you draw it, in fact, why don't we do it on a calculator? I think I already put it in radians and polar. Again, you select radian for the degree and polar for the function. Okay, and then you go to y and you plot this 3 cosine 3 theta and graph. See? But they have to be the same size. If they don't seem the same size, you can always click on zoom and select 5. You can scroll down or just click 5. So you get the x and the y are the same scale. If I make it sine, so with a different color, maybe r equals 3 sine 3 theta. So it will start right here at an angle that is half of that. So if this is 120, it starts at 60 degrees. And then you add, no, I think this would start, yeah, if this is, we said 120, 240, 360, sine, no, sine would be 30 because basically you are dividing the 90 by 3. So it starts something like that. And then 150, so something like that. And then 270, something like that. So it's rotated. So look at that. If I change the cosine into sine and graph, yep, one at 270, one at 30, and one at 150. Okay? So it gives you, if the number here, if this number is odd, you get the same number of petals. 3, I get 3 petals. 7, I get 7 petals. 1, I get a circle, which is 1 petal. But if it's even, you get twice as much. So for example, if I say r equals 5 cosine 4 theta, I will get 8. 8 petals, not 4. Look at that. Now, change, it doesn't matter, 5. And let's return to cosine and then make that 4 and graph it. Yep, 8 petals. 1, 2, 3, 4, and then at 45 degrees, I get another 4. So when it's even, you get double. If it's odd, you get the same number. So what if I need a number that is not divisible by 4? Like if I say 4, it gives me 2 4s. If I say 6, it gives me 3 4s or 2 6s. So I get always a number divisible by 4. But suppose I wanted a 10 or 6 petals. I want 6 petals. Then you draw these two together. For example, let's go back. Say the first one, keep it as 5 and make that 3. And then come down here and say 5 sine 3 theta. Now I should get 6 petals. I don't know why it went. Oh, it doesn't matter. Oh, I didn't plot this. Yeah, so when I click, oh my God. No, let's go back. I think because I did it, I have to clear clear that. And let's go here and say 5 sine 3 theta so that it draws them together. Yeah, both of them would be drawn. Why it didn't draw the, yeah, here it is. Again, they are not equally spaced because when you divide by 3, so basically, yeah, it works. It's not, it doesn't look nice, but if you want to make it nice, then probably you increase the number of petals. So we can do, for example, let's take this out and make that 6, so you get 12 petals. Okay? So try to remember that for next Valentine when you send a card to your sweetheart, and then you can just send them an equation, right? In fact, next time I will show you how to draw a heart, a cardioid, a heart, using that. So now you have a heart and a flower, and oh my God. So when you send the equations, you will get back, okay, sorry, I don't want to see you again. I hate math. So anyway, just kidding. Sorry. So today we learned how to draw a straight line, a circle centered at the origin, or a circle that touches either the x or the y, either to the right, to the left, up, or down, and finally, how to plot a rose. And the rose depends on, if you want an odd number of petals, you use an odd number. If you want an even, then you have to get twice as much as you enter. Okay, I hope this was easy enough. And uh, I will have a more advanced session probably later today. But if you already know this material, maybe you will like the next one. If not, then I will keep going later and give a session on the other types of like a lemniscate or a cardioid or some of the famous graphs that we can plot with polar coordinates. Okay, thanks for your time and hope to see you soon.